Hello everyone. Today I'm going to tell you how to write equations in Tecplot. Okay, I will tell you more than that, and couple of more things. For example, how you're plotting isosurfaces and slices as well, and you can make an animation video in Tecplot. But most importantly, how to write equation. Why am I doing this? Because I once I needed it, and I tried to search it, but I could not find things at one place. So I have gathered things from different websites, and okay, so finally I was able to do my part. So sometimes it becomes very useful in research, where uh, you have to plot some new variable with the help of variables given in your data file. Okay, so how you are going to calculate, what if that variable is coming after a bunch of multiplication, division and all. So usually in other languages, for example MATLAB and Python, it's everybody knows and information is readily available, right? But here I could not find, so I'm going to try to help you out. Okay, fine. So let me load the data file first. So my data file is from ANSYS, so I will have to load hang on. So I will have to load case file as well as dat file. Okay, so let me just do this here and right. So if I'm going to try to load this, okay, here, so you have to in case of ANSYS fluent file, you have to load both the files, case file and dat file. Okay, so here I just loaded both the files. Okay, and then let me just show you. So if you want to write some equation, right, you are trying to calculate some new parameter. All right, so you will go to in data section, alter, then specify equation. So with me I already have equations, so I'm going to show you here that what are the variables that you have here. Okay, so can this window be increased? Yeah, it can be. Okay, fine. So I hope now you can see here you have this velocities, temperature, okay, density and total temperature and Nusselt number, heat flux and whatnot. Okay, now this is the information about the data, but what you need is you need to write equation here. Let's say if you're trying to calculate some equations. Okay, I'm going to make this window a little bigger so that you can see properly. Okay, here now, so I already have the equations that I made for my work, so I'm going to just load that equation. So what you can do, you can just write some parameter, let's say anything here, and then you can save it. Okay, its format it will automatically consider, and then after saving that equation you can load it at any time. Okay, but don't worry, I will explain how I have written those equation and why I have written everything. Okay, so here is my equation. Okay, it seems complicated, but I will explain one by one. Okay, so then what I do, all right, so here I am defining a new parameter. So whenever you define a new parameter, is it visible? Okay, I think so. Just hang on. I think font size is not going to increase here. Okay, so here, so this is the first variable that I have defined, that is RA. So that is Rayleigh number. So for multiplication it is simple, you put a star, and then for power you put double star, just like in Python, that the way you do it in Python. Okay, then I have, and every variable that you define has to be in braces, right? Sorry, this curly brace. Okay, and then another parameter I have defined Prandtl number, that is also going to be in curly bracket, and that is 5.7. Then these are the new parameters that I have defined. Okay, so you can zoom the video and you can find out. Hang on, so here all right, and then again g gravity, and I have new variable this dt. For me it is temperature difference, and then capital H is just the length, and then another parameter that is t mean, all right. Now finally what my equation is, this is my equation, okay. So I'm trying to calculate heat flux at every location in my domain, okay. So I have that domain, fluid domain, in my data file, and in that I'm going to calculate what, heat flux, right. So what I can do, this is the formula given to me, okay. So how I can show you, I can tell you actually. So I'm going to tell you the formula once, then I'll tell you how I wrote it, okay. So T minus T mean upon T mean, that is one non-dimensional, I'm non-dimensionalizing the temperature, into Vz vertical velocity into alpha to the power minus 0.5, that means 1 upon root alpha g dt, okay. So instead of doing that root on the bottom, I have taken everything on the top. That is why those parameters alpha, g, dt and h, they are in power, okay, and they have minus sign, so that means they were in actually denominator. So in the, and but by the way you can divide it, divide it and square root. I have done that. Here I have done differently. So you can take square root by taking sqrt, and then whenever you write those parameter you have to put it in curly bracket, right. Rayleigh, PR, alpha and everything else. So in this, what is the parameter that I'm taking from the data file, and what is the parameter that are new that I'm defining. So this is how you do, right. These are the new parameters. So in the beginning that I have shown, so Rayleigh, PR, alpha, these are new parameters, and from the data file I'm taking this T and I'm taking this Vz, only two, okay. Rest of the parameter I have defined, and I'm trying to calculate Q, okay. But I'll, now what I will do, I will compute, okay. So it is showing some error, okay. First error is invalid variable name, somewhere variable name is invalid, and then what is showing, error occurred near position marked with @. So whenever you see @, you will know what is the error. So firstly it gives error here, and where it is located by this @, okay. So see, this variable capital T that I'm taking from the data file is invalid. What else? If you'll fix this error will shift to Vz. I know that because I have taken this parameter Vz on my own, but actually, and missing expression, but by the way missing expression is sometimes it gives error, but even though there is no missing expression, so don't worry. So try to put the right variable name, okay. So how I'm going to show you, see, z velocity, I was taking Vz, but here parameter name is z velocity. So you can just double click on this parameter, and what you can do, Vz, okay, that's it. You change the parameter name in your data file itself. And next is, next parameter that I'm taking is total temperature, but I have taken as T, right. So double click and write here T, all right, okay. Now it should not give any error, and it will compute properly. See, data alteration successful. Now let me walk you through the data set info now. Once you do that, see, alright, so I'm going to show you those parameters. See, you chose these parameters, now they are being evaluated in the variable info. Rayleigh, PR, alpha, G, dt, H, T and Q. Q, that flux that I was calculating at every location, at every node point in my data file or in my domain actually, is being reflected here in Q, okay. Is it clear? Now what you can do, you can just close this window. Now processing, so this shade comes, I'm going to switch it off, and I'm going to try to create isosurface. So isosurface isosurface icon is here, it is given here, you can see my cursor, isosurface, and then here. So if you'll click in the information part here, so you will see here your every parameter is given, and your isosurface for example constant pressure is this, but I want to know the isosurface of that new parameter q. See, it is given in q, so you select that q from this file, and then you can change the color, by the way. So I always choose a small rainbow thing, so here, and you can set the new label. So you just, all you have to do, you just set minimum to maximum. Okay, so I'm going to change it, let's say from 0 minimum to 0.2, let's say. Okay, okay, see, this color changed, and this is how you can pick any variable and you can have isosurfaces. Now here you can change two isosurfaces close to a value. For example, if you'll take specified value 1, then you can put one value. That means these isosurfaces are for zero point 0.1 value. Okay, whatever value, whatever that parameter can be. Now you can have this two specified value, then you can specify two value, and now you will have contours specific to that. Okay, fine, but what you can pick three values, so contours isosurfaces will be shown near all those values. So what I'm going to do is I'm going to pick all the contour surfaces, so you can group them. Okay, by that option only it will change automatically, you can see. Okay, see my contour group labels, so you can pick that. Okay, I'm going to close it. You can rotate it just to see here. So these are the contours for equal values. Okay, now let me just switch it off isosurface, then you can do these slices of yeah. So here you can make animated video, right? You press here, I'm going to do that from minus 0.01 to 0.01. I'm going to give the frame rate, that means number of steps. Number of steps I'm going to divide 100, and then I'm going to click play. Okay, I should here see. I can replay it, it's pretty amazing. See here, and on the contour bars you can do that. So there are multiple things that you can plot here, and these are basically contour in a plane, and since I'm moving it with respect to location, that's x-axis, right? It is moving towards x-axis. Now what you can do is you can do that with horizontal plane as well. Nice. So that's the horizontal. I'm going to switch others off here. Now if you'll play, okay, this is, let me put it 100. Oh, not that one. Okay, that is also off, on. Fine. So that is done. Hang on, let me switch that off. 6. See, that one is going to be on. So this vertical plane you have to switch it off. I think I have left it on somewhere. 2, 3, 4. Yeah, 4 is on, so that is why. Now if you'll play, yeah, see, so they are symmetrical on the corners. Okay, fine, close. So thank you so much. Do tell me how whether you liked it or not, and you can ask your doubts or any questions by putting it in a comment section. Do give a thumbs up and share the video, and if you need I would be really glad if I could help. Okay, thank you.